And square coil people, notice the circuit is a little bit different. We had to do something funky here. The square has roughly equal perimeter to the circular coil. This one has 200 turns, and this one has only 50 turns. Same with the triangle. It's equal perimeter, but it only has 50 turns. So keep in mind that at the end of the day, whatever results you get for your magnetic field, we're probably going to want to multiply by 4 if we want to compare the square to the circular, at least in terms of your experimental data. So again, these have 50 turns. In order to make this experimental data comparable to this experimental data, you got to multiply by 4. Now look at the circuit. It's a little bit different. Because it's got fewer turns, there's also less resistance, so smaller voltage is an issue here. So what I did is I just dropped in a 1 ohm resistor here in series, and you can see it goes out of the power supply through the 1 ohm, and then it goes in through the coil. Also notice this elaborate, very important duct tape here. That's just to make sure that these things aren't flopping around and short-circuiting to each other, okay? So you could do something similar if you want. I just didn't want to have a short circuit between here and bypass the coil. It's not a big deal if you have the 1 ohm resistor in there, but okay. So notice, if you have 3.6 volts and 1.0 amps, we must have a total resistance of about 3.6 ohms. This is 1 approximately, so then we must know this is about 2.5 ohms. So from that you could roughly figure out the resistance or the length if you needed the exact number of turns or something like that. Also, something you should do is when you're measuring these things, maybe you could measure them with a DMM to get an extra sig fig, right? So you could put a DMM in series here and get the actual current. That way you have one more sig fig. And then you could adjust the current and make sure the current's just right to 3 sig figs instead of just 2 so that your data looks a little bit better. Alright. Now, what I've done here is I've set this on 100 times sensitivity because it's a smaller number of turns, we get a smaller magnetic field. And now I'm going to come over here. I've got a magnetic field sensor, and I'm going to set it up on the bottom one, which is 100 times instead of 10 times. Alright, and then I'm going to go ahead and have this readout in Tesla, I guess. Oh, let's have it read out in Gauss. It'll be fewer leading zeros. And now I've got this display up here for magnetic field strength 100 times. We'll drag that down here to the graph just so I can see it, and I'll also grab it and drag it down to digits. So now I've got that going, and let's go ahead and hit start. There it is. Okay, and so as we bring this thing closer to here, alright, I'm just going to be bringing this in and out. Now let's watch what happens. I'll bring it in and out and also towards the edge of the coil, and let's see what happens. So if we bring it towards the screen, well, I guess you can see the data right there. Right now I'm in the center of the coil, and right now I'm at the edge of the coil, and we see it doesn't saturate. So that's pretty good. Alright, we can see we can get negative and positive. And then when you're far away, notice you also get this kind of background field right here. It's not exactly at 0. I didn't really take care of that. Hopefully you will do that. But so you should be able to get some data. Let's see if you can get 2 sig figs here. Looks like we'll get about 2 sig figs, so that's pretty good. Or we could turn the current up maybe to 2. Hopefully that will keep this thing from melting. Alright, so now the current's at 2. Let's see if we spike out. We're getting close there. Okay, so you see when it hits the number 10, we're saturating. So maybe you actually want to use something like 1.8 amps. That way you don't spike. You don't quite clip. Okay, so something like that. You figure it out. But now keep in mind, something you got to think about is whatever current you use for this coil, you probably want to use the same current for the other coil, and then all you have to do is multiply this set of experimental data by 4 to match this one. Or you can think about doing something clever where you multiply the current and the number of turns by an appropriate ratio to make the experimental data match up. That's something you got to think about. And then again, you could also take this loop off and do the same thing down here. Whoa. Come on, get off of there. There we go. This thing's getting hot. This thing's getting hot, so that's a lot of current. We might have to figure something out. Alright? So maybe 1 amp is a better idea, because this thing is super hot. Maybe we'll have to use several 3 ohms in parallel to cut that wattage or something. But in any event, yeah, you could do the same thing here where you go around and get B as a function of XY and make a contour plot in MATLAB. Alright, that's it for now.